All right, I'm going to get started right at 3:15. So today's talk is about mobile and Azure App Service. I'm going to explain to you what Azure App Service is and why it matters in the context of mobile. Let me introduce myself first. My name is Donna Malieri. I'm a program manager on the engineering team for Azure Mobile. And that includes both Azure Mobile Services and Azure Mobile Apps. And I'll tell you exactly what the difference is between both of them. And hopefully it will make sense. It's a little complicated because some of the same words appear in both services. So if it's totally confusing, just raise your hand and say, what are you talking about? And if you want to reach me on Twitter, my handle is Lindy Donna. If you have questions at the end, I can also give you my card. Now, all of you have just had ice cream, I believe. So I'm fully expecting a sugar high, at least for the first 30 minutes. So is everyone excited? Yeah, great. Now, your sugar high is going to wear off, and then that will be up to me to make the talk interesting. So I'm breaking up this talk into about 4 sections. First, I'm going to explain what Azure App Service is. It's a relatively new service, and why that matters in the context of mobile apps. In particular, the new things in Azure App Service really light up a bunch of enterprise scenarios that I'll talk about. It's not just enterprise scenarios, but that's one of the big features. The next big thing is the web apps part of App Service and the power that that brings you to mobile. And I'll spend most of the talk digging deep on offline sync on mobile clients and how you as developers can build this into both your back-end APIs and your client mobile apps. Just as a point of order, this talk is mainly geared towards developers, but I will be talking about scenarios that are enabled. So even if you yourself are not a developer, I will be showing scenarios, and there'll be some boring code parts that you can ignore, but everyone should be able to understand the scenarios that are now enabled. So Azure App Service, who here has heard of it? Oh, way more than I thought. So it billed last week. Only a handful had heard of it because it's a really new offering. It launched about a month ago. And it's more than just a name and a brand and a lot of services that have the word app in them. So let me start at the bottom row. There's 2 completely new services that are called Logic Apps and API Apps. And I'm not going to go in depth on either of these. In fact, I'm not going to go in depth on anything except for mobile apps, because otherwise it would be a 4-hour talk, quite literally. But I will show you pointers to other talks where there's more of a deep dive. So if there's some feature that sounds really cool to you, there's a talk about that. So Logic Apps are a kind of a rebooted workflow. It's a completely rewritten thing. It has actually no relationship to Windows workflow. But it does give you a workflow editor inside of the Azure portal, and it's this really nice web drag and drop, but also has a code view. One of the things that differentiates it from traditional workflows is that these are now cloud components. So you can orchestrate multiple cloud services or services you've built yourself. They can be connectors that you provision from the gallery. And you orchestrate between them in this nice UI. Now, you don't actually have to, if you don't like workflow editors, you don't have to use things this way. There's also a web jobs feature in web apps that I'll demonstrate. And I'll point you to a talk that goes deep on Logic Apps. The next part is API apps. And these are the APIs that either third parties write. Microsoft has some first-party API apps, or you yourself can author API apps for your own services, either services that you have in-house or some third party that you've provisioned. And these are essentially both hosting and management operations for building APIs. Now, for the purpose of this talk, the top line is what's relevant. So web apps is actually not new. Just the name is new. It is literally just Azure websites renamed into Azure Web Apps. So if you've used Azure websites, who here has used Azure websites or has them in production? Okay, a fair number of people. You are using Azure Web Apps now. The reason for the rename was not just to be cute and use app everywhere inside of App Service, though that is kind of nice and cute, but it's pointing to a trend that's in Azure websites and now Azure web apps, the same exact trend. And that was that you can use web apps as more than just a place to host your website. You can use it as a general hosted compute platform that offers you a lot of benefits over other services like cloud services. With cloud services, you get a lot more control, but with Azure web apps, you get like 5-minute deploy, even faster actually, for my little demos, and no downtime, testing in production, staging slots, backup restore, all kinds of great features for having a hosted service for running some kind of back-end code. It could be a web service, it could be a website, it could be static HTML, it doesn't matter. And web apps is going to be very important because of how it ties into mobile apps. You can think of Azure mobile apps as the V2 of mobile services. How many here are familiar with Azure mobile services, either by playing around with it? Oh, just a small number, it looks like. Okay, well, so then I will tell you what Azure mobile services is and how it differs from Azure mobile apps. And the key part is that Azure mobile apps runs on Azure web apps. And that enables a whole set of scenarios that weren't ready, that weren't easy to do before. So to summarize, you can automate business processes with logic apps. You can, with API apps, you can build custom APIs or consume available connectors from the Azure Marketplace, and you can build orchestrations and logic apps that use these connectors. So let me explain what I mean by connector. They're going to go into far more depth on this, on the API apps talks and the logic app talks. But for instance, there's a Salesforce connector in the marketplace, and you can write a logic app that has orchestration with that. There is an SAP connector, there's a Dropbox connector, there's a Twilio connector, and you can build your own, and we're building out more and more of them. One of the key new things that, as it pertains to web and mobile, is that you can write code that shares both your data access and your business logic. And you can do this either by using one of those connectors that I mentioned, by building a custom API app, or just literally putting the code in the same site. So now the same site can serve both web and mobile clients, which was not possible before. Another great thing is that you can actually save money with your hosting plan. Now all of the app services are going to be hosted on something called an app service plan. This is basically a renamed version of the hosting plan in websites. But the reason it's been renamed is now it applies to all app services. And that means that you can pick a VM of a certain size, and then you can put in as many apps as you want into that, as long as that works with the load that you have. So as a concrete example, suppose you have a website that has a lot of heavy traffic, and then you have a mobile app, back end to your mobile app, that doesn't get as much heavy traffic because you have mobile client devices connecting to it, right? And you don't want them to be really chatty. That's going to waste data usage. It's going to increase data usage. It's going to have a bad impact on battery life. So now your website needs to serve a lot of traffic. It needs a lot of memory and CPU and network connectivity. But your mobile apps need to connect to a back end that doesn't really need as much. So you could host these two together and pay just one price for the VM that you have on your, both your web and mobile app. Does that make sense to everybody? I know some of you are new to these services, so let me know if something's unclear. All right, so by your silence, I'm assuming that you've perfectly understood all of this. So I promised I was going to link you to some other sessions. There's a ton of them. I'll put this again at the end of the slide, but there's going to be a talk specifically about logic apps, and it's going to show a whole demo with the drag and drop and the connectors and even the architecture, and that's on Thursday morning. There's a talk on API apps and some specific important concepts there, such as the gateway, single sign-on, and API connectors. So I'm going to mention the gateway of API apps, but I'm not going to go into any more detail because it actually offers a lot of capabilities. So I want you to see, if you're interested, I want you to see the session or parts of the session to really get a good sense of what's going on there. From the web perspective, there's two talks. One is on Friday. It's going to talk about dedicated hosting plan called App Service Environments, which you can use for web and mobile, and of course the other API apps as well. I'll mention briefly what that is and why that's useful. And then there was a talk recording that you can also watch, which is about the DevOps features that are enabled with Azure Web Apps. One point I should make when I go back to, let me go back to the previous slide here. One point I should make here is that anything that you see that talks about Azure websites, except for this brand new thing about the app service environment, every other thing applies to web apps and websites equally. So if you go back and you find a talk from last year or 2 years ago, assuming that it's hasn't been superseded by something newer, all of that still applies to Azure Web Apps. So I realize that might be slightly confusing for customers, but you just change the word site to app and you're all set. So let me talk a little bit about how people are using mobile services today and how you can kind of move on in this. Customers can take these same scenarios and broaden them now that there is this broader offering of app service. So for my first example, I'll talk about a consumer app, which is called Sleeve Music. This is available for Windows Phone. It's a very nice app, so if you have a Windows Phone, I recommend you try it out. And the idea of this app is to allow users to discover new artists that they might be interested in. So not just Pandora-style thing where it's just suggesting new things, but it's more about a deep involvement with a particular artist and kind of expanding their music horizons. So they actually did start using some of the new features in App Service. I mentioned connectors. There's a Twitter connector, which you'll see in more detail in the API app session. But they're using this feature with a new rollout that they just did, where they allow you to follow artist updates. So this is particularly interesting if it's a local artist, and you can follow their Twitter feed right within the app and find even related artists. So it will suggest to you, hey, there's a concert playing with an app that's similar, saying the word app a lot, with a band that is similar to other bands that you like. So that's what they've done here. And this is a nice example because it shows you how, in order to build a really great app, even if it's just a consumer app, you really need the power that you get with the back end. You wouldn't want to be doing all this complicated processing in a mobile client. And even more so if this is going to be a consumer app that is for some enterprise, right? So Alaska Airlines, for instance, has a really nice app. They're obviously connecting to their back-end systems. So to move on to enterprise apps and employee apps, there's this really nice story with 3M. They had recently acquired a business around automatic parking meters and automatic payments and payment collection and that kind of thing. But while they had a lot of operational data into how these sensors, how these meters, were working, they didn't have a nice view from a business side of things in terms of how many are deployed, what kind of revenue is coming in, and that kind of thing. The reason they needed this was because they wanted to now go and sell this product to people, to customers, and they wanted something really simple and really easy to use that a salesperson could go into a customer and say, see all these places we've deployed this, we've got these satisfied customers, you yourselves should be our new customers. Now, here, they really needed to use offline sync because if you're a salesperson, I'm not a salesperson personally, but I assume if you're a salesperson and you go to a client's office and you're like, oh wait, hold on, I need a signal, just give me 5 minutes. What's your Wi-Fi password? Your sales probably not going to go very well. So they built in offline sync into this as well, so they could get the updated data, have it ready when they're talking to the customer, the potential customer, and also getting updates. Now, the fun thing about this story is that when they were talking about the business requirements with this, the business leader said, oh, I really wish we could just have an app that showed all this information. And the dev said, oh, that's going to be so easy. I've used Azure Mobile Services. I bet you I could build that in a weekend. And his boss said, okay, go do it. Build it this weekend. And so then he got a little nervous because he didn't actually expect that someone would take him off on this offer of building an app in a weekend. But he did it. He had some familiarity with Xamarin Forms. He hadn't actually used mobile services in great depth before, but he knew what kind of capabilities were available. So in that weekend, they built the first version of the app with Xamarin Forms and offline sync. So that's the kind of developer productivity that you get with this platform. And more along the lines of enterprise use cases. So the construction industry is not necessarily known as being at the cutting edge of tech, but That doesn't matter, right? Just because a business is a very well-established one, that doesn't mean they can't take advantage of new technology and really differentiate themselves from their competitors. So Skanska is such a company in the construction business. They were bidding on a job site that was right next door to a hospital with a neonatal care unit. Now, you can imagine the hospital was really concerned about having jackhammers and dust particles coming in because the neonatal unit is actually very sensitive to those things. So the way Skanska solved this problem is with technology. They had sensors that were in the particular areas of the hospital, which were collecting all the detailed information. And then they built a system, a back-end system on Azure that would collect the data from these sensors and send push notifications to the construction foreman, and also an app that would let them see the current status. So they were informed well before there was any kind of hazardous situation. And as you can imagine, a hospital is going to be very happy about that kind of thing. So those are some real examples. I'm going to tell you a fictional story about a customer who is using app service to change their business and differentiate themselves from their competitors. And I'm going to use the same example throughout the talk, and I'm going to show you different pieces of a whole system that fit together. So first off, how many people here have heard of Fabricam? Fabricam, does that ring a bell? Yes. Fabricam is Microsoft's one of Microsoft's favorite fictional companies. And Fabricam really likes Microsoft also. And the Fabricam executives at Fabricam Cable were at the app service launch, and they said, hey, this is a perfect way for us to beat our competitors, because who here loves their cable company? Just a show of hands. Okay, that's what I expected. Literally no one raised their hands. No one likes their cable company. For the sake of argument, let's suppose that Fabricam Cable is in a location, geographic location, where there's a lot of competition. As we know, that's not always the case in all parts of even the US. But they really want to beat out, if you're a fan of 30 Rock, they want to beat out Cabletown. And the way they're going to do this is by providing a really awesome customer experience, and they're going to use app service in order to deliver this customer experience. So first off, they're going to say online appointment booking. You don't have to wait on hold with customer service for an hour, only to be told that your appointment is going to be in like 5 weeks or something ridiculous like that. They're also going to send you push notifications and SMS alerts when your technician is on his way and when your appointment is confirmed. And then they're just going to go crazy and promise a 10-minute service window. Now, this may not actually be physically possible. I realize that. But for the sake of argument, let's suppose that they have hundreds and hundreds of engineers on call, and there's some complicated logistic system that I'm not going to show that dispatches the engineers out. But the idea here is that they're trying to build upon their existing assets, and they're going to use web and mobile technologies in order to offer this great customer experience. So what I am going to show you is the first two, the online appointment booking, the push notifications. I'm also going to show you the actual engineer, the service engineer that goes to your house, the kind of app that they're going to use, and how that ties all back into their back-end systems. So the first step is that a customer will book an appointment on a mobile app. I'm not going to show that in the diagram below. So one of the ways in which they're revolutionary is that they don't have customer service representatives. They have customer valets. And those customer valets are going to aid the customers on their customer service journey. And the appointment request is going to come in. The customer valet will see all the open appointments for a given time slot, and then they're going to assign an actual technician to go to the person's house. Then, with this web app that the customer valet is using, that web app is going to create a new case in a CRM system. In this case, I'm going to use Salesforce. You could also use Dynamics. We have a connector that works with Dynamics as well. We have several CRM providers in the Azure marketplace, and you could always build your own connector to whatever system you're using. So the web app is going to create a new case in CRM, and then the logic app, which I'm not going to show, but I am going to show the push notification. The logic app is going to send a push notification to the customer to say, hey, your appointment is scheduled. And there's more stuff that I'm going to fill in here, so that's why there's all that blank space on the right. So let's look at this in action. Let me show you what the customer experience is, the customer valet experience, and the fact that cases are created in Salesforce. So I'm going to switch to my Windows machine. I also have a Mac that I want to use to show you the Field Service Technician app. So here we have Visual Studio, but first I'm going to show you the Customer Valet app. Now this is an existing app that Fabricam uses for other things, such as their car service. And now I am playing, oh, I missed a step. I was too excited about being the service valet. First, I'm going to be my boss, Kirill, and he is the customer. He launches the Fabricam customer service app. You can see I have it as a Windows Store app. And this app is going to connect to a separate service that I'm not going to show, a Fabricam, that is listing all available appointment times over all possible technicians. So Fabricam, as I said, Fabricam Cable is awesome. So he can get an appointment tomorrow at 1 p.m. And here you can say exactly what's wrong. Cable is busted, and then you submit. This is going to submit a case that the customer valet is going to see. And then they're going to assign something. So let's go back to the customer valet. Let me refresh this. So this is using Salesforce and doing a bunch of single sign-on information. So the problem with that is that you can have stale browser cookies. So let me connect again. And let's refresh the Salesforce token. So now see, I'm actually playing the part of the customer valet here. It's my Salesforce account. It's going to be her picture in the valet app. But this is all done. This is again one of those details I'm not going to go into, but this is all done through the gateway of API apps that you'll learn more about if you go to one of those talks. So now I am logged in. I have the photo of Carla, the customer valet. I'm pulling down all of the active requests from customers for, let's suppose that I've drilled down to a particular time slot. So now I pick the customer as Carla. I should say Carla picks the customer, clicks next, chooses a technician. Bob is actually a very, it's kind of a Renaissance man. He does many things more than just repair cable. And he also seems to be an actor from his headshot. So I am going to send, Carla, I should say, is going to send Bob Johnson to Kirill's house in order to replace his cable box. And this is going to, this UI shows the possible repair requests or I should say the possible work orders that Carla is going to assign to Bob. And here she already looked at the ticket and she says, okay, replace Kirill's cable box, and then click next. It's all going to be confirmed. Now, let me make sure that, so I quit the app, and what's going to happen is that a new case is created in Salesforce, and there is a logic app that's looking for new cases for the logged in user. In my case, it's Kirill, and it's going to send a push notification. So here it is. That's a push notification to the customer app. So that's the customer valet side of things. Let me show you Salesforce to show you that it did indeed write through. And you can see here there is a case that's created. So this is kind of like the internal ticket that's being tracked. It's going to be assigned to Bob, and it has a bunch of customer details. And that's the entity that the field technician is later going to update. So I'm going to go back to the slides. And I'm going to go into great detail on this later, so I'm not going to show you the UI yet. But this is the UI that we're going to look at in detail and see how offline sync works. And this is what the technician sees. So this is the app that Bob uses when he goes to the customer's house. And what he'll do is click that box at the bottom to close out the work order and to say exactly what work was done. And that's going to go all the way to Salesforce. So if I were to write kind of a component diagram of the different pieces of this app, first we have a backend for the customer app. We have the customer valet web app, which was that service technician app that Carla was using. Logic apps are going to send customer notifications. That's the part of the app I didn't show you, but I showed what it does. And there's connectors that are used by all three. In this case, I'm using Salesforce and Office 365. Oh, I forgot to mention a key thing. When I was dragging an appointment, when I was Carla, and I was dragging the case onto the calendar, I was actually creating an event on Bob Johnson's Office 365 calendar. So he's going to get in his calendar, but he also has that field technician app that I showed you earlier, where he can actually manipulate the work order entity in Salesforce. And so logic apps are connecting to notification hubs, which I'm not showing here, but that's what's being used in order to send the push notification. That's an Azure feature. And it's using Salesforce. And then there's the technician app backend. I showed you what the client looks like, and I want to drill into detail on what both the backend and client code look like. So I said that Azure Mobile Apps is really Mobile Services v2. And not a lot of you were familiar with mobile services, which is fine, because I can explain to you what mobile services is and what v2 mobile services is, and all the new capabilities that are now available. So this is a diagram that we often show for mobile services to show the different components. So we have some mobile SDKs, which have offline sync enabled. That'll show up in a separate animation. From the top to the bottom, there's data connections that you use in your backend code. That can be SQL, tables, Mongo, et cetera. There's user authentication features. So there's social providers as well as Azure Active Directory. There's full support for Active Directory, including both the client flow and the server flow if you're an Active Directory aficionado. And then there's integration with push notifications through Azure Notification Hubs. A feature that we've added recently, which is still part of mobile services and applies equally to Azure Mobile Apps, is offline sync. And about a year ago, we announced the preview of it, and now it's generally available for most of our client libraries. So it's available in Windows, Xamarin iOS, and Xamarin Android, and Xamarin Forms, as well as native iOS and native Android, and with more platforms to come as time goes on. So with mobile services, you would write your backend code in either .NET or Node.js. You'd write JavaScript code that would handle particular events, particular CRUD operations, create, read, update, delete. So you got a REST interface that matched all of these database operations, and you could write scripts that do something either before or after the request is received. Or I should say, when the request is received and before you write to the database, you could do something, write to the database, and then have some post logic. When mobile services launched, it only had the Node.js backend, and what we heard from customers is, hey, I'm not a JavaScript developer, I want to use .NET, and how many people in the room does that apply to? Just a show of hands. How many of you are .NET developers? Okay, most of you are .NET developers, not a surprise. And so they said, hey, I want to use .NET. And so we said, fine, here you go, here is .NET. And so we extended Web API and provided kind of a subclass of a Web API controller, if you're familiar with Web API, and that's called a table controller, and that's where you would put in all this logic for the create, read, update, delete operations. But then we went further and extended it more so that you could have all of these data sources and plug in whatever data source you want. It's really extensible. Now, with Azure Mobile Apps, we've gone even further with regard to the data connections. And now you can see it's only a small square in the data connections box, but it's very important, and that's API apps, which means all of those connectors I talked about and all of the connectors that you'll see in the other talks on logic apps and API apps now can be used with Azure Mobile Apps. And just as a point of clarification, the word app and mobile appears a lot when I'm talking about different things. When I'm saying Azure Mobile App, I'm referring to your backend. So you could also think of as your app backend. And your client app, which I'm going to try to distinguish between that without saying mobile app, is the thing that's on your device. So as a developer of an app that runs on a device, you will write two pieces of code. You write the actual app code that runs on customers' devices, and you typically also will use a backend. And the Azure Mobile Apps gives you that backend, plus a bunch of SDKs and client functionality for writing your client code. The other thing that has changed between mobile services and mobile apps is this backend code. So we added, I said we added .NET. First we had Node.js. Now what we've done is opened up the compute container entirely to you. So in mobile services, the compute container is abstracted from you. You actually pay for API calls, and you have limited control over what size VM you want. And the advantage to customers is that there's a ton of monitoring. There's a bunch of things where we can check that the data connections are all working, that your SQL database connection string is correct. We can patch the runtime for you. But what we heard from customers was, well, I like abstraction, but I want a little less abstraction. What they wanted was a better compute container, a less abstract and more powerful compute container. And what a lot of them were already Azure Web Sites customers. So what they asked for was, well, first off, all the features in Azure Web Sites, or a lot of people said, I like these features, give them to me. Even more people said, just make it a website. That's the thing that I have. It's a web API. I can run it in Azure Web Sites. Has all kinds of fantastic features. That's what I want. So that is the big change with Azure Mobile Apps, is that now the compute container is completely opened to you, but it's still a hosted service. It is not as abstract as a VM or a cloud service. You get like a 2-minute deploy, just as you did with mobile services. That hasn't changed. But you get a lot of new features. So concretely, you get all of the hosting benefits of Azure Web Apps. You have Traffic Manager, you have custom CNAMEs, you have VPN and VNet. You can have fine control over what kind of VM size you want, how many instances you want, staging slots, in production A/B testing. There's a ton of great features. Let me explain what in production A/B testing is, because that term might not be the most clear. What that means is that when you roll out a website or a backend of your mobile app, you can decide that only a certain percentage of your customers will get the new site, and then you can see how that experience works. So let's say you want to roll out a new feature, but you're kind of not sure if customers will like it. So you can use the in-production A/B testing in Azure Web Apps to do that. And you get web jobs, which are long-running jobs that are running on this web app host. All of these things are now available to you. And so this is why I said watch all of those Azure Web Apps talks, or even the older Azure Web Sites talks, because that is the compute container for your mobile app backend code. So more accurately, if we're going to talk about app service, if we look at the runtime view about how things are physically running in Azure, we're going to have a view that's more like this. When you create an API app or a mobile app, you actually get a web app underneath, and that's the thing you deploy your code to, and that's the thing that you can scale and do all these great things to. You can also scale everything within your app service as well if you want to. But you can always get to that underlying web app, and that's where you can set up the VPN. That's where you can set up your staging slots and your backup and restore. When you deploy in Visual Studio, you'll deploy to the web app code and that kind of thing. Logic apps have their own compute container, but they consume API apps. So indirectly, they are consuming web apps. So that's why this diagram looks the way it is. And I'll show you in the Azure portal what this looks like when it comes to mobile backend apps. And right now is when I'm going to show you that. So let's switch to my demo machine. And let's go to the Preview Azure portal. So I have a lot of browsers open here because I have a lot of different logins. So that's why I'm using Chrome. It's not because I prefer it. I actually really want to use Spartan, but I was afraid of Windows 10, and I already have demos that are kind of fragile, shall we say. So that's why I'm still using Windows 8.1. So this is the new Azure portal. How many people here have played around with this or have even seen a view of it? Handful. I guess it's probably about as many as have tried out Azure and provisioned resources. So if you haven't tried out Azure yet, I should let you know that you get a free 30-day trial with no monetary commitments, and you get $200 worth of credit. And I'll also show you a web page you can go to at the end where you can sign up for a 1-hour app service, either a mobile app backend or a website or a web app. And you just log in with a social provider and the site is yours for an hour. So you can play around and see, does this really do what you want, all the capabilities of that. So I really encourage you to try out this portal if you haven't already. Oh, and I forgot to mention, if you're an MSDN customer, you just activate your MSDN Azure benefits, and every month you will get a certain amount of credits. I think it's like $120 or something like that if it's an ultimate subscription. So I also recommend doing that because it's just free compute. So here is the new preview portal in contrast to the classic portal, which has a slightly different view. And what you can do with the preview portal is pin different services to the startboard. So kind of similar to Windows 8, you can pin different things. And these can show you information. So here, for instance, the repairs advisor, this is the back end, or the site actually hosting the customer valet app that I showed you, where Carla Davis was connecting and doing everything. The code is all running inside this web app. And if I were to drill in, I can see all kinds of statistics and information about how it's doing. So there's just the general information about it, the requests and errors, the quotas, the auto scale feature, and that kind of thing. So let me go, since this talk is focused on mobile backend apps, let me go into that. Oh, and this icon here is the Logic app icon, which I really like, even though at first when you look at it you don't know exactly what it is, but I really wish our service had a spaceship icon, because that's just so cool. So let's go into our mobile backend. And what you'll see here at the top is various pieces of data about your service. Let me zoom in here. Oh, maybe that was a little too zoomed in. I think I can just... Is that big enough for everyone to see? So here what you'll see is something called a resource group, which is a logical grouping of your various Azure resources. If I click on the resource group, what I'll see is everything that's been deployed here. And here I have the mobile app. That's kind of housing all of the features that I talked about with push notifications. It has your app and master key for protecting your API and that kind of thing. The gateway is the thing that's shared between all the app service apps. The gateway is what you'll hear more about in Logic apps. But that's a common place to put your authentication code. That's what you should think of it. And you can use that across all of the app service app types. And here in Field Engineer Lite -code is the actual backend code. So you can also get to this right from, let me collapse this here. You can also get to it right here from this blade or this part that's within your app service, your mobile service. So here you can see all the same information, your subscription, your resource group. You can see your requests and errors. You can see I have a very, very regular set of requests and errors. That's because I have a web job running in this backend, and there's a feature called Always On that will just keep pinging your site, because otherwise IIS will unload your site, because to save resources, it'll see, oh, you're not doing anything, I'll just shut you down. But if you have a web job, you are doing something. It just doesn't look like HTTP calls. And so this is going to show you your request, your errors, and if I go to all settings for my code site, I will see these are the settings for your underlying compute container. So here there's remote debugging. There's remote debugging. There are your app settings. You can say whether or not they are specific to your site or just a staging slot, and that's where you do where you can have two sites and you can swap between them, the auto swap feature in Azure websites. So if you're not familiar with these features, I really recommend seeing an Azure Websites or Azure Web Apps talk. And the other part that I should show you is your plan. The app service plan is in your code site. And that's, the reason it's here is because this is your compute. So think of your app service plan as the physical resources that you're using to run your apps. In this case, it's my backend. And the resource group is a logical grouping of your resources, which could span multiple hardware configurations. So here I could change the pricing tier for this. Now I happen to be using the same pricing tier for different app services that I have. So if I were to scale this up, then those will also get scaled. But if I wanted really fine-grained control, let's say I said, okay, my mobile app is not going to get a ton of hits, so I'm going to put that on like a really small VM, but my web app is going to get a ton. I don't really care about using the spare cycles from the web app into the mobile app. So you could choose to have two different app service plans in order to manage the traffic there. And back on the main page for the mobile service, what you'll see is those features that I talked about. So authentication. This is actually going to go to the gateway. That's the API app part. In mobile services, we also had authentication, but we did it ourselves. We had our own gateway, and that was specifically for your own mobile service. Here it's potentially for multiple services. These are the keys. These are the app keys, the master key and application key that you would use during testing in order to ensure that not everyone can hit your site. You can even distribute that with your app as well, but it is slightly discoverable because someone can look at your app binaries. So it does give you some level of security, or I should say obscurity. And then this is where you get to your push notification settings. When you get Azure, either Azure Mobile Services or Azure Mobile Apps, you get a certain number of free credits for notification hubs. So when you buy the two together, you actually are going to get a better deal, because with mobile apps, you'll get some compute plus some notification hub credits. And notification hubs is a service we've had for a while, so I'm not going to go into the specifics, but you can see that you can use multiple different providers for the push notifications. And that also means that you can have one app backend that can serve multiple mobile clients. So you could write code that sends one notification. In your code, it looks like just one notification. And you can really easily write logic that figures out which client is on what platform. I should say, actually, notification hubs knows which client is on which platform. And then your code can just say push to send out the notification. So it's really nice for that as well. And I realize there's a lot here that I'm not going into the details about. It's because each of these are themselves their own 15, 20-minute talk at the very least. But if you're interested in these things, just search on Channel 9 for talks on notification hubs. There's a number of really, really excellent talks. So these are the different features in the portal. And so, for instance, here I can see my CPU percentage, the scale. This is the same as what your site is running. And this is interesting because if you're a mobile services customer, you'll know that you only got some very high-level information about your service. You would know about requests and responses and errors, but you didn't know about the underlying compute, because that's the thing we were managing for you. Now you can have full control. You can decide how much memory your VM is going to have, what services are going to go on it. You can decide to choose these super expensive premium VMs should you choose to do so. So let's go back to the slides. So I've already covered the difference between the main differences between Azure mobile apps and Azure mobile services. The places where they differ has to do with whether or not you can use API apps and the hosting options. And I basically already said all this. You have a lot of control over your compute environment, but it's still a hosted service. You get really fast deployment. You get automatic OS patches, all kinds of great stuff. So if you want to use mobile services, you should go into the classic portal, the manage.windowsazure.com. For mobile apps, that's only available in the preview portal, so it's portal.azure.com. And right now, we're missing some features in Azure mobile apps as compared to mobile services. But by the time we GA, and probably long before that, we'll have built out all those features. So right now, the service is still in preview. And once it's generally available, you'll have all those great things that are in mobile services in the context of Azure mobile apps. But your existing investments are safe. If you have mobile services, you don't need to worry. If you want to create new mobile services, It's not a problem. I know sometimes people get worried when they see a new product come out and they want to know what's the state for the old product. So this is a service. We're not going to just shut it off or kick you off or force you to migrate or anything ridiculous like that. However, Azure Mobile Apps is still in preview. So if you see some stuff that's like just not great, that's the time to tell us, because we can do something about it more quickly than if you're looking at an established product. And so since mobile apps is our new product, that's where we're going to put all the new investments. But mobile services is still fully supported. It has a full SLA. Services that are in preview don't have a full SLA. They have a partial one. And once we have general availability for Azure mobile apps, should you choose to do so, you can migrate seamlessly. And we're not going to just push you over or anything crazy like that. In other words, we're going to offer you a carrot in order to migrate, which is these new hosting benefits and new features. But there's no stick. It's just carrots. So if you have an existing mobile service, you can choose to keep it on mobile services if you want to. If you're changing the backend code in any way, these new features will probably come in handy. If you have a service that's just sitting there, going along nicely, there's no changes that you have to make, it's perfectly fine to just keep it on mobile services. So now that I've talked about mobile apps and what it means in the context of app service and why web apps are suddenly so interesting when it comes to mobile backends, let's go back to our favorite Fabricam example and see how they create that mobile backend and how they enable offline sync and how they're going to write through to Salesforce essentially from the mobile device. The experience is going to be that the technician changes something and that change is reflected in Salesforce. So just to reiterate this, remind you of this diagram. Customer valet was assigning a technician. There's a new case in CRM, which we saw. Now there is a new piece. There is a web job that's going to synchronize the CRM data, in other words, the status of the case, with a custom SQL database. And despite whatever CRM system you're going to use, you almost always have your own database. In the case of the cable company, they're going to have a list of all their equipment. They're going to have their manufacture date, their warranty, who's assigned to what technician is using what equipment, and that kind of thing. So you often need to synchronize and integrate multiple systems. And this is a really, really simple way of doing it with a web job. So this is just a demo example, but you could do something more full-featured if you wanted to. Now, the reason that this all matters, aside from the fact that it's more real world to have a SQL database, is that now your mobile backend code, and this icon is for mobile backends, and so that's why it has a little compute object inside of the phone. That's what that represents. So what it's going to do is it's going to read data from SQL. So it's going to have a really efficient read. It doesn't need to aggregate anything. But when there's a change, it's going to write through to CRM. It's actually going to write to the database and also write to CRM, so that it ensures that those changes are reflected immediately. So if the case is closed, you don't want to wait 15 minutes or however long your synchronization is happening for others to know about the case change. So let's look at this backend code and how it all works. So I'm going to switch back to my demo machine. And this time, I'm going to go to Visual Studio, which is probably what everyone here likes to see if you're developers. This is a nice, safe home. And what I have here, and I hope this is big enough. Is this big enough for everybody? OK, great. Sometimes it's hard to tell with different screen resolutions. So what I have here is a solution with two different projects in it, and I'm going to actually deploy both of them to my same backend code site. So Field Engineer Lite service is the code for my backend. This code is actually really similar to what it looks like in mobile services. So the things that are changed are the things around authentication and those connections, the gateway and the connections to other resources. But I'm not going to show you the gateway and things like that. So a lot of what you're basically, in terms of the code that you're seeing here, it still applies to mobile services as well. So what we have here is a job controller, which is our endpoint where the mobile clients are going to connect. And they're going to connect over Rust, and they're going to call these various HTTP verbs. So they're going to do get to get a job instance, post to insert a new one. So that's the C in CRUD, and so on. And here, almost all of this is exactly the same as the default scaffolding that you get when you add a new mobile services table controller. The one change that I've made is in patch. Because as I mentioned, I am reading from SQL and I'm writing through to Salesforce. So that's the one part where the thing changes. And the way I'm connecting to SQL is here in the constructor. This is the line that does it. So we have a number of domain managers, as they're called, inside the backend. The backend NuGet packages, I should say. And one of them is for Entity Framework. So this will do Entity Framework with SQL, but we also have one for Mongo. We have one for table storage. It's extensible, so you can write your own. For instance, I wrote a domain manager that goes straight to an OData source. So that's one way to really easily connect to different data sources. So here I'm just connecting to Entity Framework. I'm using a plain old SQL Azure database, so I don't have to do any customization. By default, that scenario is what you get out of the box. It's pretty easy to change it as well. So that's how I'm doing that connection. When I want to do my write, and that's the patch HTTP verb, and so what I'm going to do here is update. This update async call is a method that's in the backend framework, the mobile services backend framework. So this is just going to update the database. And then what I'm going to do is call the Salesforce connector, which is represented here with a Salesforce client. And I'm going to send an update. Basically, the way the job number is mapped within the SQL database. In the SQL database, it's a number, it's an integer. In Salesforce, it's a string. So I'm going to do a conversion here. And I'm going to say what work was performed and what the new status is. The web job that I'm not going to go into great detail about, but basically it's a web job that runs every 30 seconds, and it does the synchronization. It's very boring synchronization code, so I won't bore you with that. But it's using the same exact Salesforce helper. Here I'm just doing a cheap code sharing by linking to the same file. So I don't know if you can tell, but there's a little link there. I'm also going to just use the same job entity, which looks like this, and the same database context in my web job. Then what I'm going to do is deploy to my web app. Actually, at this point, let me show you what it looks like to create a new one. I'm not going to make you wait for all the provisioning, but what you do is the plus button for new, you go to web and mobile, and you'll see this is where all the other app services are. So there's web, mobile, logic, API app, and things like this. There's also third-party ones like Umbraco. So here you would say create a mobile app. You'd enter a name. So in my case, I had like field engineer. Let me just say Donna M1 since I already have one. And then I would set my SQL database settings. Here you would pick your app service plan, and along with their plan is what your pricing tier is. So there's a bunch of different plans here on my subscription. So if I were to pick Donna Test Plan, that's in the basic tier, and that's going to decide the subscription and the location. Because, but I can create a new resource group here as well. So the reason, if you remember what I said about the app service plan, that's the physical layer of where you're running. So my VMs are physically located in the South Central US data center, and they're the basic size. And of course, I already have a mobile app created, so you don't need to sit through all of that. So let's go back here. Now, when it's time to deploy, what I do is publish. It's the same gesture that you would do for mobile services, by the way. And the difference, though, is that in mobile services, you would have seen a different target here. It would have said Azure Mobile Services. because, as I said, we had our own compute container, so that's why you had to deploy to that specifically. Now, as I said, we run on Azure Web Apps, so you get all the same fantastic tooling and all these great options with web apps, and that means that you're going to deploy your code to the web app. So here, I can pick the web app that I have. You can also import a publish profile, which will already automatically pick it. You can see I already picked it before, that's why it's showing up there. At that point, however, in the previous slide, I could choose to even provision a new web app at that point in time. So there's a lot of options for where you want to do your provisioning. You don't just have to do everything in the Azure portal. And at this point, it's going to do a web deploy. It's going to set my SQL connection string and all of that. So I'm not going to show all of this again, partly because I'm worried I accidentally changed something and break my demo. But you'll have to take my word for it that it takes 1 minute literally to deploy. And the reason for that is that it's a hosted, web apps is a hosted environment that isn't creating whole new VMs each time a customer is deploying to them. They have a bunch of VMs already set up, and then you just deploy to them, and everything is nice and happy and good. So that's how the patch worked. So I'll go back to my slides. So what I showed you so far was only the read and write operations. Up until now, I haven't shown you anything with offline data sync. That was my secret ploy to get you to stay till the end of the talk. So let's look at how that works. Despite the fact that I've talked about a lot of new features in mobile apps, the offline sync features are exactly the same. The difference with mobile apps is that now you have more options for your backend data sources. So like in my case, I had Salesforce. But when it comes to the capabilities of offline sync, you have both of them. So as you know, the best mobile apps are going to handle network interruptions gracefully. Unfortunately, most of them don't. And that's because adding sync to an app is really, really hard. It's not just more code. It's not just caching things onto your device. The problem is that most of the time you want more than just a read-only cache on your device. You want to be able to modify data while you're offline. And then, at that point, you get introduced to a whole world of pain having to do with conflict handling and different people modifying the data at the same time, freshness problems. If you had a read-only cache on your mobile device, and then you want to pull down newer data, and you want to, let's say you have a read-only cache, and then you're pulling down more recent data. Now you, as an app developer, have to figure out how to reconcile these two pieces in terms of what you're showing to the user, right? Because you had some stuff cached, now you're showing some new stuff. You need to make sure the user is going to see the same thing. And this is by far the main reason, in my opinion, that most apps don't bother with offline sync support. At most, they'll do a read-only cache, but even then, as soon as you connect and sync, they'll just wipe away everything and restart. And that's not great. First off, it's not a great user experience. Second off, it uses a ton of data, which is not great, depending on whether or not you have a paid data plan or not. You have to always have network connectivity. But worst off, sometimes your app is just being used somewhere where you can't ensure network connectivity. So the example I gave with the people who are selling the 3M parking meter technology, they can't be depending on their client's Wi-Fi or whether or not Verizon happens to be working in whatever shielded building they're in. Or the cable technician that I'm going to show, right? They're going to someone's house. You know, it's not acceptable for them to say, well, I really would close out your work order, but I have no signal. We have more examples of customers who are, in oil fields and they need to take meter readings, and it's just not acceptable to be forced to be online all the time. The good news is, with Azure Mobile, both mobile services and mobile apps, it's really, really easy to add offline support, and you get conflict handling and all that great stuff. So, to summarize all of what I just said, at the very minimum, you want to cache data on your device because nobody likes it when you launch the app and now it's like pulling down the whole world of data just to let you manipulate it. And there's two scenarios. One is the scenario I usually have where I step into an elevator and my app stops working, and that's where I'm usually online, but there's intermittent network connectivity. And the other case is someone in an oil field or a service technician where they're going to be offline a lot and they're going to be creating new data, and they want to make sure that that data they created is safe and is actually going to get synced back up, and it's not going to get overwritten by somebody else, and that they can handle conflicts and they can be productive with their mobile devices. Another scenario is if this is mainly for consumer apps, but it can also be for work apps, and that's where you want the same data on multiple devices. So for a sales scenario, you want the same CRM contacts on multiple people's devices. But you don't want to pull down every single CRM contact that's in your database, because first off, that's pretty bad for your UI, and second off, it's going to use up a ton of space on your device. And the key thing that's really tricky, usually, in most sync solutions is the conflict handling. And I'm going to show you exactly how we manage conflict handling for you and how you can plug into that. So the way it works is I talked about those create, read, update operations in mobile services. And the mobile services and the mobile apps client SDK uses that same abstraction in order to decide what to save offline. So basically, only the read operation won't make any modifications. So in other words, the create, update, and delete operations are things that need to be tracked. And so it's going to keep a queue of all those modifications that you've made. When it reads, it's going to read locally by default. You can do a remote read if you wanted, but it's usually easiest to have your local database be completely in sync with what it is that you want to show the user. And then you can detect conflicts if the same item is changed by two different people. We also support a feature called soft delete, which I won't show the exact details of it, but I am actually under the hood using that in the Salesforce example. In Salesforce and in most CRM systems, you can close a case, but then there's also a concept of deleting it. In Salesforce, you delete it. In Dynamics CRM, you deactivate it. Now the problem is, this only gets introduced as soon as you introduce offline sync, is that now you have these stale records on the client device, and how do you get rid of them? This doesn't happen if you're always reading what's the freshest data. And so that's why even when you're doing a read-only cache situation, it's still hard to implement this yourself. So one cheap solution a lot of apps will do is periodically they'll blow everything away, or they'll just hope that you don't see those dead records, or they'll only sync the most recent things. But that's not really a good solution for an enterprise app. And another thing I won't show here, but you can imagine how that works, is you can use push notifications to trigger the client to sync. So all the mobile device platforms have something known as a raw push notification, though it's called different things in different platforms. What you can do in your backend code is determine that a certain client, or maybe all clients, need to synchronize again. So maybe it says, maybe I'm a sales representative, I have some new contacts. The backend code will send a push notification to my devices, and then my client would wake up and synchronize records. Or maybe on the next time it launches, it will synchronize the records. So then you don't always have to poll for new changes. So going back to the example that I had, the backend was going to read from SQL, or is reading from SQL and writing through to CRM. And now the mobile client SDK is going to sync its own SQLite database that's on the client device with the Azure mobile backend. So there's something really important to note here, and that's that notice how the clients are not going straight to SQL or to Salesforce. This is really, really important architecturally, because this means that when you write your client code doesn't need to care about where the data is. It just works against the abstraction that you've provided in your backend. And therefore, what that means is, let's say later I say, oh, I actually have another CRM database, or I have another SQL database that I need to connect with. You put all of that abstraction in your mobile backend code, and your mobile client code, unless there's new UI, doesn't need to change at all. Or maybe there's just a new entity. It doesn't care where that came from. It just goes to the backend. So this is really different than older sync technologies, like, for instance, merge replication and things involving SQL CE and sync framework and all those things, where you were actually mirroring a database on both sides. And that introduces a lot of problems, not the least of which is that the server is maintaining the state of every single possible client that is ever synchronized, which puts a ton of load on your SQL server, but also that it fixes your backend data source, and it cannot be changed. With Azure mobile services and mobile apps, you can have anything. You could even have a web service in the middle. and completely abstract that away, and your clients can now sync against that. So let's look at how this works in code. So now I'm going to switch to my Mac. Make sure that's the right. Oh, it's. Nope. I was right the first time. All right. So I'm running a little short on time. So what I'm going to do is go through the code a little quickly, but I'm going to show you the end state. So right now I have some mock data, because I basically have built the UI for this field engineer app, and it has no real data source. So that's why it's showing all this silly lorem ipsum stuff. And I am going to show you in just a few minutes how quickly I can connect to mobile services and have offline sync all at the same time. So first, let me initialize my mobile client. I'm going to do this with snippets so you don't have to watch me enter everything. So here is where I would put in the gateway URI for authentication, but I'm not going to go into the specifics of that. Then I initialize something called a sync table. And this is the thing that tracks all of those changes that I've made. And also, when I read from it, it's going to read from my local SQLite data store as opposed to hitting my service. Now I need to initialize the actual local store I'm going to use. So here, I'm using a SQLite store. This is extensible. You can choose whichever kind of data store you want. You have to implement a particular interface. But if there's some other client-side technology that you want to use, you can. And so here I'm going to give a database name, localDB Fabricam. Let me use C because I think I've run this app before and I want to make sure I have a fresh database. Then I'm going to say what table I want, which is job. I have a similar job class defined here. It has fewer fields because the mobile client doesn't need the full glory of what's in Salesforce. I'm going to initialize the sync context, which is basically tying together my sync tables with my sync store. Now I'm going to read from the local database. There's support for querying that I'm not going to, or a different version of the app let you query specific things. But here I am just, notice here I'm saying job table.create query, and in the case where there's no query passed in, I'm not sending that query. This is reading locally. So until I have synced, there will be no results. Or the very first time, I should say, there will be no results. Every time I sync, I'm going to be setting up the local store, and subsequent reads will go to the local store. Now, when the technician marks the job as complete, I am going to update. And this is, if you use mobile services, this is literally the same line of code that you write. And here, this is how I do the sync operation. You'll notice the code is really simple. What I do here is I push all of the changes that I've built up in my sync context, and that's done through a push async call. And then I'm going to create a query that's going to be done for all of my pull operations, which is to get just this particular field engineer's cases. And so every time I do a pull, it's going to use that particular query. And if I wanted, I could write multiple queries, but just for the simple example, there's just this one. So let me save, stop the existing app, run it. Okay, now there's no data. This is a good thing. This is not a demo fail. That's because my app is not online, and I have not done my initial sync. So when I did my read, I'm reading against the local store, which has nothing in it yet. So what I'll do is I'll move this to online, which will trigger a refresh operation. And now, so now I'm Bob Johnson. Before I was Carla, now I'm Bob. And I can see the various work orders that are assigned to me. So if I click Kirill's work order and I say, okay, I have replaced the cable box, I mark this completed, and this is going to change the status both in the local database and online. Actually, let me go back offline. Let me pick somebody else. Let me mark this one completed. So my local database will say that Matthew Henderson's work is completed. However, Salesforce will not. So you can see here, Kirill's case is closed. But Matthew's case is still open because I haven't done a sync yet. Now, when I go online and refresh, what will happen is it's going to hit the database and change the status. So you can see here, now the case is closed. So I think I won't have time to show you the code for this, but I am going to create conflict and show you how that works. So here, let's go back offline. So we have this case for Omar, which is not opened. This is this one. Upgrade equipment. Let's go here. Let's change the title. Okay, so he's really upset with the customer service. Let's make the priority higher as well. Hi, and the status is still new. I didn't actually show this in the correct time order. I'm the technician. I'm still offline. I'm going to say, oh, I fixed everything for Omar. I'm done. And so the field technician leaves and thinks everything is ready. So I apologize for that complicated ordering here. Now, Carla Davis is going to get a call from Omar that says, oh my God, you just sent me the worst possible technician in the world. Everything is still broken. You better not have closed my case. And so we changed the subject here. We save. And we say that he called. And now the field engineer is going to go back online and refresh his data. And we will see that I have a UI bug here where this was showing it's not complete. And here, and I think I have a bug in my sync. This might be related to the fact that I'm using a web job to synchronize, which is not exactly the most, oh, here we go. So the status is somehow not set correctly, but the title is set. Now, if I try to complete it again, the change will be rejected. So I apologize for the fact that you didn't actually see it all working, but if you look at the recording of my build talk, you can just watch the last section of it. You'll see the conflict handling. And the way it works is it uses something called version column, which in this case is mapped to SQL row version. And so the backend is going to reject updates when the row version doesn't match. In this particular case, I've set it so that the client, the changes that are coming from the client have a lower priority than those that are already in the backend. And the reason for that is that we don't want the technician to overwrite data. So I have gone over, which is the worst sin of a speaker. So I'm just going to go to the end of the slides. However, the full slides will be available. You can look at them at your own leisure. Let me just bring up the evaluation slide. And so you can watch these fun animations later, but this is explaining exactly what I was talking about with the sync conflicts. And so to summarize, with mobile offline sync, it makes it really easy to build offline sync enabled apps. You can use a lot of data stores. We have a lot of client SDKs. I showed a demo on iOS using Xamarin. You can do it with native iOS. We have some pre-built apps that you might be interested in, a field engineer and a sales assistant. There's a CRM connector for dynamic CRM, which is going to be demoed in the theater sessions if you want to see those. There's some new hosting environment, which you can see in one of the later talks. And I think most of you took photos of the upcoming sessions, but go ahead and feel free to do that again if you want. And if you go to these URLs, you can try everything for free for 1 hour, or activate your MSDN benefits, or sign up for a free 30-day Azure trial. So please give me feedback on this session. I'd love to hear what you thought. Thank you. So any criticism is welcome. I realize I went over time. You can mention it again in the notes if you want to. But I will update the session with a bunch of pointers and links and samples so that you can see all this content that I didn't actually get to.